All right, so when we are solving with factoring, a couple of important things to remember. It has to be set equal to 0. So it can't like equal 4. It has to equal 0. Our first step is to always check for a GCF because sometimes that is the easy way to do it. And then we're going to be factoring, and that's going to use our X and box if needed, or X and split the middle, or there's about 8 different ways of doing factoring. And if you know a way to do it, you're probably fine. But I'll probably work with the box mostly in here. Okay, so these are our steps. So we're going to set it equal to 0, check for a GCF, and then factor. So our first one that we're going to do, remember how to do this, looks like this. 12x squared minus 2x equals x. So this is our first equation. And our first step is to set it equal to 0. So what do we need to do in order to get this thing to equal 0? How do I make this side 0? Subtract x from both sides. I need this side to be a 0. My 12x squared doesn't change. And I have minus 2x minus x, which is minus 3x. All right? So then what we're going to do is try and factor out a GCF. I want to look at these two pieces and see what do they both have. What do they both have? 3. What else do they both have? X. So if I take 3x out of both of these terms, what's left over? What we're really doing is I'm taking my 12x squared and dividing it by 3x. So what's left over? 4x minus 1 equals 0. And that's factored form right there. Those are our factors. The way this helps us get solutions is we look at our factors and we want to know, when does this chunk equal 0 and when does this chunk equal 0? Yes, dear. That came from us dividing the 3x, the minus 3x that's here, by the 3x we pulled out as a GCF, by 3x. So this gave us our 4x. This gave us the minus 1. Okay, cool. So to find our solutions, we look at each of our factors individually. We want to know when 3x equals 0. And we want to know when 4x, that should be purple, 4x minus 1 equals 0. These are where we find our solutions. What can I do on this one to get x by itself? Divide by 3. Divide 0 by 3, what do we get? What is 0 divided by 3? 0. I have no cookies to split among my 3 friends. Everybody gets no cookies. The purple one's a little more complicated because what do I need to do to solve and get x by itself? We're going to add 1. 4x equals 1. Then we're going to do what to get x by itself? Divide by 4. So we get x equals 1/4. So our two solutions here are x equals 0 and x equals 1/4. We're putting them as ordered pairs. 0, 0, and 1/4, 0. Because remember, these are our x-intercepts, our roots, our zeros, our solutions. If you remember that they're x-intercepts, it's easy to write them as ordered pairs because it's whatever x equals, comma 0. And you have just algebraically solved our first quadratic. These guys are our solutions. Questions on this first one? So it's really, really, really important that we check for a GCF every time, because if we didn't, this would be a lot harder to solve. So it's really, really, really important we check for a GCF. Then we're going to remember how we do this without. Why do I have that there? Without a GCF. Pretty much every method I know still uses the x prime in some way, shape, or form to factor, where we have our a times c at the top and our b at the bottom. So this is the same standard form. Somebody's music is so loud I can hear it up here. This is the same standard form we have over here, the same place we got the b and the a to find our axis of symmetry. It's the same guys. All we're going to do is we're going to take a times c, just the numbers, over b. B goes at the bottom. And what we're going to do with that is we're going to find a pair of numbers that multiplies to make the top number and adds to make the bottom. Those pieces are going to go here and here. What these pieces tell us is how this piece splits apart. It's uncombining the like terms. And I'll show you what we mean. We'll go through this a couple of times. But we are going to be using factoring, no joke, through May. So we're going to be factoring bunches and bunches and bunches over the next course of when we get back from break, a couple of weeks. Because no joke, we use factoring through May. It's one of those things. If this is something that's hard for you, we're going to want to practice, 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 because we use this through the year. So we're going to practice it. Our first step with solving a quadratic is we need to set equal to 0. So equal it to 0. What do we do to make it equal 0? Subtract 18. So we're going to have x squared minus 6x minus 27 equals 0. Then we're going to check for a GCF. Ooh, that's not a pen. Is there anything that all three pieces share that I can take out? Well, x squared isn't divisible by 3. So there's not anything there. So we checked. Go team. We did it. We didn't have anything, but we checked. Then we're going to try and factor. So what we're going to do is I'm going to draw that x. We're going to take the a times c at the top. B goes at the bottom. So what is the a value here? It's the one in front of the x squared, so it's just 1. What is our c? Negative 27. So 1 times negative 27 gives us negative 27. What's our b in the middle? I was like, but don't put the x in the frame. Just negative 6, because the b is in front. The x is still here. So it's just the negative 6. Now what we're going to look for is a pair of numbers that multiplies to make negative 27 and adds to make negative 6. And this will be the part that's tricksy sometimes. So what I'm going to do is I'm going to make a list of factors. Things that multiply to make 27. Positive 27. 1 and 27, an option. 27 doesn't divide by 2. It does divide by 3 and 9. No 4s, no 5s. Won't divide by 6. I think that's it. So since we need a negative 27, what we're looking for is which pair of these has a difference of 6? 3 and 9. One of these is going to be negative in order for my product to be negative. Which number, 3 or 9, needs to be negative so that my b is negative 6?
9.
The 9. What this tells me is that before we combined like terms, this was really written as x squared plus 3x minus 9x minus 27. So if we think about when we multiplied and we put all 4 pieces in the box, those are the 4 pieces. So if you are a boxer, mathematically, not physically, sports-wise, these are our box pieces. X squared, 3x minus 9x minus 27. So if you like to use the box, this is the way to do it for you. There are other ways to do this. You can do this with a grouping method. You can do this with a bottoms-up kind of method. To get to our factored form, what we're going to do is we're going to pull columns and rows, our greatest common factors. So it's just like doing GCF on the last one that we did. So I'm going to zoom this way in for us to see real quick, because I want us to not look quite so far. All right. What is shared in this first column between x squared and minus 9x? Just an x. What is shared between 3x and negative 27? 3. What is shared between x squared and 3x? And what is shared between negative 9x and negative 27? More than just the 9. What else do they have? The negative sign. So our factored form is going to be, and I'll write it right below the box. X minus 9 and x, if there's nothing written there, it's a plus 3. I'll zoom it back out for you guys. And that's our factored form. So we factored. Questions on the factoring part? Because then we've got to solve. We're almost to the end of this one. Yes, sir?
If we have a greatest common factor, the box method would still work, right?
Yes, you just pull your GCF first. We're not going to do any like that before break, because we just have the 1 day of this and then like we get ready for the quiz. But we'll do more factoring after break that will have that. All right, so then we've got to find our solutions. I'm going to give us a little bit more space at the bottom, which means I got to change my view. So our solutions are when each of these pieces equals 0. So we want to know when does x minus 9 equal 0, and we want to know when x plus 3 equals 0. That's how we use factoring to find our solution. So what am I going to do on this one to figure out what x is? Add 9. So we're going to add 9 to both sides, and we're going to get that x equals 9. On this one, what are we going to do? Subtract 3, and we get that x equals negative 3. So our two solutions are 9, 0, and negative 3, 0. So the factoring you guys have done before, but it's been like a year. At least. Probably. So it's one of those things, once we get back in the groove of it, we'll be all right. But it just takes some practice to get back in. Because this is the only real new part, I think. I don't think you guys solved with them. But you did all this part. So let's practice it again. We're going to practice it again. Same process. We are going to set equal to 0. We're going to check GCF. We're going to factor. We're going to solve. And you can use this list as a checklist. So first thing we need to do is to set it equal to 0, which means what are we going to do? Subtract 1 from both sides. It's going to give us x squared plus 3x minus 10 equals 0. So we set it equal to 0. It's an important step. Then we're going to check for a GCF. Is there a greatest common factor in all of these pieces? Nope. Don't look too hard. If you don't see one right off the bat, it's probably not there. I'm not going to sneak them. Then we're going to factor. Since I have my 1, 2, 3 pieces, that's when we use our x. So I'm going to take my A times C at the top. B goes at the bottom. So what's my A value? What's my C value? What are they multiplied together? Negative 10. And what's my B? 3. So I'm looking for a pair of numbers that multiplies to make 10, or multiplies to make negative 10 and adds to make 3. So when in doubt, if you ever get stuck, make a list of factors of this top number. Things that multiply and make 10 are 1 and 10, 2 and 5. And since we're looking for negative 10, I want to know which pair of these have a difference of 3. Which pair have a difference of 3? 2 and 5. I need them to multiply to make a negative 10, which means one of these numbers needs to be negative. Which one needs to be negative so that my B is positive? The 2. That's kind of the way we figure out which one's negative, is we're going to have to logic our way through it. That gives me the pieces to put in my box. We're always going to take our x squared from our equation. We're always going to take our c term, that minus 10. The only things we take out of our x frame are those numbers on the side. The minus 2x and the positive 5x. The only thing the x frame is good for is to figure out which two numbers this used to be. That's it. The top number we don't use for anything else. The bottom number we don't use for anything else. Do not put the A times C or the B in the box. They don't go. So let's come in here and pull our factored form, and I'm going to change our view so you guys can actually see this. So what is shared in this first column between x squared and minus 2x? Just x. Ooh, that's not a pen. What is shared between 5x and minus 10? 5. What is shared, top row, between x squared and 5x? Just x. And what is shared between minus 2x and minus 10? Negative 2. So our factored form is x plus 5, x minus 2 equals 0. And that's our factoring part. Now we're going to add in that solving. So we're going to come down here below and we're going to say, all right, when does x plus 5 equal 0? And when does x minus 2 equal 0? So with our x plus 5, what do we need to do to both sides? Subtract. So we're going to have that our x is what? X is negative 5. On the right-hand one, what are we going to get? Positive 2. There we go. So our solutions are the points negative 5, 0, and 2, 0. Okay? So factoring we've done before, solving we've done before, we just hadn't smushed them together yet. Okay? That's the last new stuff before the quiz. That's it. Okay? So, there is some work on Alex about graphing quadratics and solving quadratics. There is a review on Alex for the quiz. Since we have an e-learning day on Thursday, which is normally the we work through the review together day, I wanted you to be able to get that feedback right away on that. I do also have a paper review that I'm going to pass out to you. I already have the answer key for the review. I have the video recorded, but apparently I've hit my upload limit on videos for the day yesterday, so it's got to get posted, I think, tonight. I didn't know YouTube had a limit, so I was recording individual videos for individual questions, and then it got real grumpy at me. So I'll get the videos up as soon as I can. Okay, but they'll get up before tomorrow. But this is the review, because I'm also not going to be here tomorrow. And we're sure going to have our quiz on Friday. What's up? Okay. So here's the review. And there's also a review on Alex. There's also graphing work on Alex. I will give you points for all the Alex things. You'll probably want to bring your Chromebooks tomorrow. You can work on the paper review. You can work on the Alex review. Do a thing and get yourself ready for this quiz on Friday. All right, but you guys have the rest of today to work on stuff. Get things turned in. Do stuff on Alex. Whatever it is you need to do for you.